Welcome back to Crafting Design Center. This is demonstration of application of Strom CAD in analysis and design of underground stormwater pipe. This is a part 2. If you wish to refer part 1, please go through it on our Crafting and Design Center website. Earlier demonstration, we explained that CAD Basin 1, as you can see on the screen, had reached to its maximum capacity. Because of that, the speed of the water was around more than 3.5 meters. This means that the entire road was spreaded with water and the depth of water was exceeded by 0.1 meter, which wasn't acceptable. So we decided to put additional inlet along this line. In this drawing, I have created additional layout using Civil 3D, where I put one more inlet at a change of 207 meter. I call it as a CAD Basin 3. It is connected through underground pipeline to manhole. I put intermediate manhole at 100 meter. It is again based on your council requirement, which council you work for. So I investigated the design by putting two catchment. I defined that there was a need to put additional inlet. I then put additional inlet, which is CAD Basin 3, connected to manhole. Now if I can show you the entire network in 3D, this is how it looks like. So there are some parts are popping, as you can see here. Two parts, they both will be deleted later on. So as you can see that I put additional inlet here connected to manhole, and I put additional manhole connected to manhole 1 and drains out to the main line. I then export everything into Strom CAD, and this is how it looks like. When I export the data into the Strom CAD, this is how it looks like. I have two inlets here, which was proposed earlier. I then put additional one more inlet at here and manhole as well. Then I have to select each line, add the data, basically drainage area, coefficient, and inlet type. Once I finish everything, I can start running the analysis. Before the running analysis, as we discussed earlier, we need to put data, which is discharge or catchment area, time of concentration, and coefficient of runoff. We did discuss about coefficient of runoff based on a surface, type of flow, whether your flow is concentrated, distributed, surface is pervious, impervious, and how the flow gets to the inlet. So once you put all the data for additional inlet, which I put in here, I can start to run analysis. I can define the HGL starting from normal to your ARI. Okay, this my line outfall to manhole 1 profile a GL line. This is my line 2 to manhole 1 to manhole 2, which is in a plan from here to here, and a GL line. I have sized up everything to accommodate a GL, and as you can see that I'm happy with what I have sized in here. This is my manhole 3 to manhole 4, which is in a plan. This line here, line ID 3. Now we back to manhole 3 to catch basin 3. This portion in plan, the profile looks here, and the spread of the water is 1.22 and the depth is 0.1, which is quite acceptable. Going back to catch basin 1, the spread was initially more than 3 meter. The depth was more than 0.1 meter, which is reduced to 2 meter, and 0.06, which is acceptable. This is catch basin 2, which is in plan, this line here. Spread of the water you can see, and the depth as well. So once you adjust all the criteria and including the length of the curb, length of the grate, width of the grate, slope of the gutter, everything, you can manually increase the length. As you can see on the screen, I'm increasing the length, increasing the length of the grate. So once you're happy with all of them, you can finish the analysis. You can then view on a profile. You can manually add the line, which is line ID 1 to line ID 3. This is how it looks like. You can then export this file using horizontal vertical scale. If you like the border, click the border. If you don't like the border, unclick the border. OK. You can export that as a DXF file. You can then open up DXF file. This is how it looks like. And then you can able to put it in your viewport, which I have put it in here, and print it. You can also export the file by putting name, description, and export as a line XML file. And you can open the line XML file by going into the insert line XML and click on line XML file which you defined earlier, which will update back to your original data. But if you have changed the inward elevations as well as size of the manhole, then you need to be very precaution about importing line XML file. Somehow it will give you error. I will say by using DXF file, you can able to generate your viewports and print that easily. I'm happy with this viewport. You have a result here. You can generate the report by clicking report. Whatever you want, click that thing and print it, and the report will look like this one. Basically, in two videos, we have gone through detailed discussion about how to run analysis. There is also have file. You can click on have file and read through something which you are not aware of. If you have additional information or question about how you feel about this video, please write us a comment. If you have any other technical question, please write me at mihir_sonaji1980@yahoo.com.au. I hope you enjoy this video and comments are appreciated. Thank you very much and bye now.